So in this video and in unit 3, we're going to really look at the relationship between the original function, the derivative, and the second derivative, especially when we're looking at graphs. So if we look at this graph, we want to just talk about the features of it and the intervals where y is increasing and y is decreasing. So when we look at a graph, we usually describe it left to right. And if we just look at it, we say, okay, the first thing that's happening is this graph is decreasing. It's going down from left to right. And it continues to go down until we get to -1. And then it starts going up. And this, where it changes direction, is called a turning point. And now our graph is going up until we get to 1. And then at x equals 1, the graph starts going down again and decreasing. So this again is another turning point. So when we describe a graph, we always give in terms of the x values. What we're looking at is really where the y values are increasing or decreasing, or f is increasing or decreasing. So here, like the y values are going down. But when we describe it, we say where it's happening. And so we give the x values. And in this class, we will mostly use interval notation. So we're going to talk about f, and then what does that mean for f prime? So when my function is decreasing, we know that the slope is therefore negative. It's going down. And remember, the derivative is considered the slope of the graph at that point, or that slope of the tangent line. So the first thing we're going to do is we're going to give our intervals of where f is increasing, decreasing. And our first interval, if we're going to the left, we would say it's keep going to the left because it has an arrow. So we say -infinity until we get to -1. That's the first place it changes direction. My original function f is decreasing, which means the slope is negative, and so f prime is negative. Then at our turning point, which is at x equals -1, and this is also considered a local or a relative min, which means it's the lowest value in the area. So at this point, all the points right to the left of it and all the points right to the right of it are above it. So this is the lowest point. So after that minimum, my function starts increasing. So from this x value -1 until we get to this x value 1, f is increasing, which means the slope is positive. So my derivative would be positive. Okay, then I have my other turning point, x equals 1, which this one is a local or relative max. It's the highest value in that region. Okay, and that's where it's occurring. And so starting at that point, when x is 1, until it keeps going, positive infinity, my graph is decreasing, and that means my slope is negative. So f prime is negative. At the turning points, we say that here, my slope, it would be a horizontal tangent line. And so we say that the derivative is equal to 0 at both of these turning points. So f prime is equal to 0 here and here. So again, when we're describing it, we're all talking about location of where it happens. So this is all x values. You can write this. So it's in inequality notation. You could say like x is less than -1. You could say -1 is less than x, which is less than 1. And then x is greater than 1. But in this class, most of the time, we will write it this way. So just to kind of summarize some of the things we said about the graphs. If a graph is increasing on an interval, if the graph rises from left to right, if the graph is increasing, the slope is positive. which means the derivative is positive. And so we often write that as f prime of x is greater than 0. So if they say f prime of 2 is greater than 0, this is the x value, so x is 2. It means that when x is 2, the graph would be increasing. Okay, a graph is decreasing on an interval if it falls left to right. So the y values are going down as we go left to right. If the graph is decreasing, the slope is negative, which means the derivative is negative. And then we write as f prime of x is less than 0, it means that it's negative. So then we have these turning points, and the turning points are where, so again, it's an x value, the graph changes direction from increasing to decreasing or vice versa. And turning points occur at max or mins. Now in calculus, we have another term for it. And so we have these points called critical values or critical numbers, and they're where the derivative is equal to 0 or undefined. So anytime you have a max or a min, here, the tangent line is horizontal, and so the derivative is going to equal 0. And so that's the critical value or the number. Again, we give the x values for this when we want it. It can also be where it's undefined. It looks like this more if it's undefined. It's called a cusp, and so the derivative doesn't exist there. In this class, we deal more with this than the cusp. But if I looked at my original graph, we would say the critical values or numbers, again, we would say where it happens is that x equals -1 and x equals 1. Because that's at those turning points, the max or the min. And that's where the derivative is 0. Now, if they ask for a critical point, then they actually want the coordinates of the point. So the derivative at that point, again, this is my x value, is 0. And then you'd have to find the y value. So if we go back to our graph, my critical point is this point. And so that point on the graph, if they ask for the critical point, we give the x and the y. So it would be -1, -2, because the y value is -2. And at 1, this turning point, or that critical point, would be 1, 2. So those would be the points. So make sure you're paying attention to if it asks for the values or the points. Okay, and then we have relative min or max. Again, they sometimes say local, it's the same thing. A relative min point is a point where the graph changes from increasing to decreasing. For a max, the derivative at the max is going to be 0 or undefined. And your slope f prime is going to change from positive to negative. Anytime it's a max, your slope is changing from positive to negative because it was going up and then it's going down. A relative min or a local min is a point where the graph changes from decreasing to increasing. The slope, therefore, is going from negative to positive. So at this point, the derivative at that point is 0 or undefined, but the derivative changes from negative to positive. So before that point, it's negative, and after that point, it's positive. So then we have absolute max and min. So the maximum value or the absolute maximum is the largest y value that a function reaches. And if they ask you for what is the max or min, the absolute, then you want to give the y value. If they ask you where, then you give the x value. And the minimum value or absolute min is the smallest y value that a function reaches. So if I look at this function, I have this endpoint. Endpoints are always max or min. So this endpoint is a min. It's the lowest point in this region. Then I have this local max. Then I come down to this local min. I come up to this local max. Now this max is the highest point on the graph. There's no other points as high. And this function never gets higher than this because the arrows indicate it's going down. So this is a local or relative max, but it's also considered the absolute max because it's the highest max. This endpoint is a local min. This endpoint is a local max because it's the highest point. There's nothing before it. This is a local min, local max, and then this graph keeps going down. So this graph doesn't have any local min or absolute mins because it keeps going down forever. Now there's one other feature called a plateau point, and that's where the derivative is going to equal 0, but there's no max or min. So f prime will not change sign. So the graph kind of levels off a little bit, but then keeps going up. So in this case, the derivative is positive and then it stays positive, but the derivative at this point is equal to 0. And then this one, it's decreasing, so the derivative is negative, it continues decreasing, but at that point it's 0. So that's called a plateau point. So just a summary, this kind of chart is a summary. You could pause to write it down. But we know if f of x is increasing, the slope is positive. So that means the derivative is positive, and we usually write it as f prime of x is greater than 0. If it's decreasing, it's negative, slope is negative, and so is f prime. So f prime of x is less than 0. Okay, if we have a max or min, the derivative at the max is going to be 0 undefined. It's going to change from positive to negative at this point. If it's a min, the slope is 0 undefined and it changes from negative to positive. Again, the derivative is the same thing, so it's pretty much the same wording. At a plateau point, the slope is 0. The slope will not change sign at that point. So f prime of x equals 0. It does not change sign. At an endpoint, if the slope is negative, so if you have an endpoint and then after that point your slope is negative, then that endpoint will be a local max. And when we write negative, if the endpoint is a min, then right after the derivative would be positive and the f prime will be positive right before. If it's the other way, okay, so I should say this is when it's left. If it's a right endpoint, it's the opposite. So if it's a right endpoint, the derivative is going to be, or the slope is going to be positive before that point. So we'll write negative after. And so this one, the derivative would be positive before. And if the endpoint is a right endpoint, it's going to be negative before it. Okay, so again, right endpoint, if it's a min, the function is going to be decreasing till you get to there. And f prime will be negative after. This should say f prime is positive after, or sorry, before. And this one should say before. In terms of like the endpoints and a lot of this, I feel like it's easiest not to memorize it, but to just look at a graph and think about what is the relationship and how do they relate.